How do you implement motor current limiting to protect motors? Imagine your motor working hard, then suddenly drawing way too much current. That can cause damage or even burn out the motor. So, how do engineers stop that from happening? Let's find out. Motor current limiting is all about controlling how much current flows through a motor. When a motor starts or faces heavy load, it can draw a big surge of current. If unchecked, this surge can overheat the motor windings or damage the electronics driving it. To prevent this, we set a maximum current threshold. If the current exceeds that limit, the system acts to reduce or cut off power. One common way to do this is by placing a small resistor, called a current sense resistor, in series with the motor. As current flows, this resistor creates a tiny voltage drop. A sensor or a microcontroller measures this voltage. If it gets too high, the controller can turn off or reduce power to the motor. For example, in a motor driver circuit using metal oxide semiconductor field effect transistors, the controller can disable the transistors if the sensed current is too high. Another approach uses special chips called current-limiting integrated circuits. These chips have built-in features to monitor current and automatically adjust their output. They often use a resistor to set the maximum current. When the current hits that limit, the chip reduces the voltage or turns the output on and off rapidly, a process called current chopping. This keeps the current within safe limits while still allowing the motor to run smoothly. In more advanced systems, like those using field-oriented control, the control algorithm constantly checks the motor current. It then adjusts the drive signals to keep the current safe while maximizing torque and efficiency. This method is common in robotics and electric vehicle applications. Passive components like fuses can also protect motors. If the current gets too high, the fuse blows and breaks the circuit. But this is a one-time fix and needs replacing afterward. Resistors can limit current too, but they waste power as heat and are less efficient. When designing a current limiting system, pick a current sense resistor with a low enough value to minimize voltage drop but high enough to produce a measurable voltage. Make sure your sensors and control circuitry can respond quickly enough to prevent damage. Set the current limit high enough so the motor can start and run normally, but low enough to prevent overloads. Remember that mechanical factors like inertia and friction influence how much current is needed to start and accelerate the motor. In summary, protecting motors with current limiting involves hardware components like sense resistors and sensors, special driver chips, or smart control algorithms. Each method has its own benefits and is chosen based on the specific needs of the application. Proper implementation ensures your motor runs safely, lasts longer, and performs reliably.